Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please consider subscribing to this channel and leaving a like for this video. Now, in today's lesson, we are in set theory, and basically we'll look at it will be a two-parts video where we'll look at binary operations in the first part, and in the second part we'll look at set theory. So I'm hoping to compress everything into one video. We'll see how it goes, but here we go. All right, so what do we mean when we say star is binary? Okay, what does it mean for something to be binary? So basically binary is just about two values, okay, two variables. Okay, and basically if two variables x and y are elements of a set S, and combining these two elements, any of these two elements in S, in a function defined as this, okay, star is binary if x star y will be an element of S. Okay, so basically what we're saying is that if we have any two elements of a set S, and we have a function x star y that defines the combination of x and y, any of these two values in S, then star, which is the operation on S, is binary if the produce, okay, the produce, which is the function that is produced here, will also be an element of the set S. Okay, so that is what binary operation is about. So let me give an example. Okay, so before we come to the actual example here and the examples or the problems that you will solve. So let's say if S is equal to, or it has elements 1, 2, 3, 4, okay, and x star y is equal to 2x, for instance. So this could be a definition. So we can pick any two values here. So we have what? So let's say we have 1 star 2. Okay, 1 star 2 will be equal to, we're just getting the values of x, so which is just 2, like that, which is just 2. Well, 2 is part of this set, so but we have to try all the values in here. So we can also try the reverse of this. So we can try 2 star 1 star 1, sorry, 2 star 1. So we're just considering the x part, which is just 2 times 2, which will be equal to 4. Okay, so 4 is part of this set, so we say this is an element of S, so this is an element of S. Then we try another one. Let's try 3. So let's try 3. So we say 3, let's say 3 star y. So the first element is representing x. Let's say 3 star 4. Okay, so the first element is representing x and the second element is representing y. So this would be 3 star y, so which is just 2 times our x, which is 3, and we get 6, which is not an element of S. So which is not an element of S. So from here we can conclude that star is not binary. Okay, star is not binary on S. Okay, so that is our conclusion. So simply because we got one element that was not part of this set, we conclude that star is not binary. Okay, we can give another example. I'm just going to give simple examples, then we'll see how we'll move on from there. All right, so we have this question here. So if S is a set of numbers from 1 to 7, so remember how we represent different numbers, so we can use just these square brackets. So this is representing all numbers including 1 and ending at 7 included. Okay, and x star y is equals to x is star binary on S. Okay, so we do what we did. So we can pick 1 star any number in this set. So we have maybe 2, we can say 1 star 2. So this will give us 1 star 2 produce is only the x part, so this will equal to, and 1 is an element of this set, so we have 1, which is an element of S. So we need to try all the numbers. So maybe we can try 2 star 1, which is the x part, which is 2. So this will give us 2, which is an element of S. So according to this definition of star, then we can try maybe 3 star 1, and 3 star 1 will basically be equal to 3, which will also be an element of S. Again, if we try 1 star 3, it will give us 1 star 3, which will be equal to 1, which is an element of S. We can try all the numbers simply because of the way x star y is defined. All the numbers that we're going to get will be part of this set, so we can conclude to say star. But you have to show all of them. If you're asked to show that star is binary, you have to show all of them. You have to go through all the combinations, right? So you have to go through all the combinations. Okay, so we can conclude here, it says star is binary on S. Okay, now to this question, we go to question number 11. Then I give you some tasks to do. So question 11 reads, let S be this set and let star be an operation such that x star y is equals to x plus y. Check if star is binary. Okay, so first of all, we have variables here which are constant, like p, q, and r. So what we're going to do is we're going to let p equals to any number of our choice, maybe 5 or 4, and q maybe, let's say 7, and r maybe 15. Okay, meaning that the set S will have elements 4, 7, 15. Okay, now you're asked to determine if star is binary. So you pick any two numbers. So we have x star y should be equals to x plus y. Okay, so we can pick two numbers. The first numbers, maybe we pick 4 and 7. So 4 we put on x, star 7 on y. So where there is x, we're putting 4, which is 4 plus, on y we're putting 7, which will be equal to 11. This will be 11, and where is the cursor? All right, this will be 11, which is not an element of S. Okay, 11 is not an element of S. And we try maybe 7 star 4. 7 star 4. On the x part, we're putting 7. So this is 7 plus on the y part, we're putting 4, which will still give us 11. Not an element of S. So now we can conclude to say star is not binary on S. Okay, so basically that is it about binary operations. So immediately you find one element that is not given the set, or that is not part of the set, you conclude that star is not binary. All right, maybe just one more example. All right, so suppose we have this question. So if K is this set and x star y is defined by that, is star binary. Okay, is star binary. So we can pick any two numbers. So we can pick -1 star maybe 2. Okay, so meaning that on x we're putting -1 and on y we're putting 2. So this will be equals to 2 modulus of -1 plus -1 over y, which is 2. Okay, so when we simplify, what is modulus of -1? That will be positive 1. So this is just 2 plus, or 2 minus, it will be minus because of the minus here. So 2 minus half So 2 minus half, which is basically 1.5. And we see that 1.5 is not an element of K. Okay, so we see that 1.5 is not an element of K. Then we conclude, say, star is not binary. Star is not binary. So this is how you're supposed to approach questions on binary operations. And let me just display a few workouts for you. Then we move on to set theory with the axioms. So set theory with the axioms. So this is where we'll be looking at the axioms of set theory. All right, so these are the questions I want you to try out. So if star is binary or check if star is binary for the following. So for each of these, you're going to check if star is binary. So if it is not binary, you have to show us why it is not binary. Okay, so you have to show why it is binary. If it is binary, you have to show us why it is binary as well. All right, so yeah, have a good try. Then I think in the next part we start set theory with examples on how to simplify set operations. So we'll be looking at how to simplify set operations using axioms. Right, so it's a good evening. See you in the next part.